Hello and welcome back to Daily Revision. Today we're going to be looking at Chemistry Topic 10, which is all about using resources. So let's start with the different types of resources. So first we've got renewable resources, and these are resources that are replaced by nature at a similar rate to their usage. And this means that they're unlikely to be fully used up, so provide future security, as they're always going to be able to be produced and taken. So renewable resources include wind, sunlight, plants because we keep growing them, water because of the water cycle, and natural fibres such as silk and wool because they come from animals. So the other type of resources is finite resources, and these resources renew slowly or not at all, meaning they will eventually run out, and this includes things like coal, oil, natural gas, and metals. So next let's look at water. So potable water is water that's safe for human consumption. It doesn't have to be entirely pure water, as it can contain salts such as minerals, and it usually does. So potable water can be gained easily from fresh water in a process. This fresh water is found in lakes and rivers. So first the water is passed through filter beds to remove the insoluble particles, which are the things that don't dissolve into the water. And then the water is sterilised to kill the microbes in it. And this is done using either chlorine or UV light. The thing is, the soluble particles don't need to be destroyed because that is like the things like the salts that can stay in there. So then that's how we make potable water. We have to get rid of the microbes and the insoluble particles. So, however, sometimes in some places you won't get fresh water, so you're going to have to get it from seawater, which is salt water. So you do this through the process of desalination. So one method of desalination is distillation. This is where the liquid is combined together with the salt at the start because it's in the seawater. However, the liquid gets evaporated into a gas and is separate from the salt. The salt stays in the container, the gas goes out of it. And then this gas is condensed in a separate container, making it a liquid in a separate container, which is potable water. A disadvantage of this system is that it's expensive because a lot more energy needs to be used than with making it from fresh water, because there needs to be a lot of heat applied to get rid of all the salts and keep them in one place. So another way of doing this is through reverse osmosis. This is where water is put at a high pressure through a partially permeable membrane. And basically what happens here is that water travels to the other side. Most ions can't pass through, so all the water goes through, but the ions don't, meaning they will stay behind. This is also expensive because you have to pay a lot for the partially permeable membrane. So next, let's look at wastewater. So wastewater is created in many ways. It's created in agriculture, which is farming. It's created in domestic use, which is in houses, and industrial processes that generate a lot of wastewater. So the first process in dealing with wastewater is screening, and this removes large solid particles including grit, because you can't have them in the water to put it back. Next is sedimentation. This is where the wastewater is split into two things. So it's split into solids and liquids. The solids sink to form sewage sludge, and the liquid remains above to make an effluent. So what happens to the solids after they sink? So the sewage sludge is dried and anaerobically digested. This means digested without oxygen. And this digestion makes biogas, which can be used to generate electricity, meaning it's useful. And also the dried sludge can be used to make fertilizer, meaning that these waste products actually have a purpose and can be useful. So next, what happens to the liquid effluent? So the effluent is digested aerobically, which removes the microbes and removes organic matter, meaning that it's turned this liquid into something that could be considered fresh water, and then it can be re-released into the rivers. So that's very useful. So next, let's look at alternative methods of metal extraction. So metal ore is a finite resource, and this is due to historical overexploitation, meaning that not much high-grade ore is left right now. So because of this, mining for low-grade ore isn't cost-effective, and that's really the only thing we got left. So they don't want to mine for it because they're not making that much money off it. So it's not it's not worth businesses doing. So the new methods include bioleaching and phytomining, and that's why these have to be used. Bioleaching is where bacteria feeds on low-grade ores to form a solution of metal ions. So the bacteria feeds on the ore and it generates this solution, which is called a leachate. And the metal ions in it are extracted through electrolysis. That's the way of getting them out. Next is phytomining, where all soil contains low amounts of certain metals. And plants absorb these minerals, and then if they're burned to ash, the ash can be dissolved in sulfuric acid to make metal sulfate. And then this metal can be removed from the sulfate to using electrolysis to get us just the metal. So it uses electrolysis again, like bioleaching. So let's look at the advantages and disadvantages of these two methods. So the disadvantages. Bioleaching is a slow process because it takes a lot of time for the bacteria to feed on the low-grade ore. Energy needed for electrolysis. So both new systems require electrolysis to take place, which uses significantly more energy than smelting to get it from the ore originally would. Also, there's phytomining produces CO2, so it makes a lot of CO2 when we're actually burning down the plants, which is exactly what would have been made by smelting. So it's not really that much more better for the environment than methods from before. Advantages are that it's energy efficient, meaning that most of the energy you're getting from the stuff stays within it. It's relatively cheap, which means it doesn't cost a lot of money, so it's good for businesses. Another advantage is that there's a low environmental impact, and this is because we're not digging into the earth, so it won't cause any natural disasters, and it won't scar the earth. So next, let's look at the life cycle assessment. So this is used to assess the environmental impact of products in 4 stages. So first we have to look at the extracting and processing of raw materials, so where we get them from and how we do that process. Then we have to look at the manufacturing and packaging, which is basically how the thing is put into its packaging and how it's produced properly. And then we got the use and operation during its lifetime. So this is how it's used, and does that use electricity? This is really important with things like cars where they use up fuels, so that will release a lot of emissions, that sort of thing. Also, a key thing that changes this is reusability. So for example, paper bags, use and operation, well, they're only going to be used once, so they're not very good here. However, plastic bags that can be used multiple times may be considered better for use and operation over its lifetime, as they're reusable. So next says disposal at the end of its lifetime. So this is when you're getting rid of the product. This includes things such as like throwing it in landfill or recycling it. So this is why recyclables do significantly better in this area most of the time, because it's going into a new product and it's not being wasted and destroying the atmosphere. So next, transport and distribution for entire lifetime. So an important thing to factor in as well is transport and distribution, and that's sometimes on graphs, but it's sometimes put into other areas, which is why I said 4 stages earlier. And this is like how vehicles take things from one place to another, that sort of thing. So the use of resources and waste production can be measured exactly, so we know that's always true from a life cycle assessment. However, pollutant effects are subjective, so some people may say a certain pollutant is worse than another one, but there isn't really any key evidence that can show us things like that. So another thing that causes something bad is that data is often misused in selective LCAs. So because everyone doesn't know everything, the data is often misused. So because it's subjective, they can use it to make you think what they want them to. So they only show certain data to make something seem better. So this might be done to like advertise for a certain product and push for you to buy a different one. So next, let's look at corrosion, and that's the destruction of materials by environmental substances. So one type of corrosion is rusting, and this is where iron is combined with oxygen chemically to make iron oxide, which is known as rust, and water is needed for this process. there are different types of methods to prevent rusting happening, causing prevention, same with corrosion. So first there's the barrier method, and this is all about stopping water and oxygen from reaching the iron, because if they can't get there, then no reaction can occur, and that's what we want. Examples of the barrier method include grease, painting, and electroplating. Then there's the sacrificial method, where another metal is placed around the iron, and that protects it until that other metal is destroyed and can't protect it any longer, but it lasts a long time. So ways of the sacrificial method are coating something in a more reactive metal or attaching it to a more reactive metal. So next let's look at alloys, more stuff about metal. So an alloy is a mixture of two or more metals. So we've got a load of examples around here. Bronze is made out of copper and tin. It's especially resistant to corrosion, so it's used for tools, coins, and sculptures. Gold is used in jewellery, and it usually contains silver, copper, and zinc as well. And it's not pure, because pure gold is too soft to make things like jewellery. It's not very useful. Gold comes in different carat amounts, so 24 carats of gold is 99.9% gold, and 18 carats of gold is 75%, and it slowly goes down. The percentage of gold means that 100 minus that would be the percentage of other stuff. So in 18 carats, if we had 75% gold, it'd be 25% silver, copper, and zinc. So next, let's look at some other alloys. So next we've got steels. So steels are alloys with carbon and metals. So this includes high carbon steel, which is strong but brittle and is used for construction. High carbon steel is made of iron and over 0.5% carbon, which might not seem like that much, but it makes a big difference to the properties. Because low carbon steel is malleable and is used for car body panels, and this contains iron with less than 0.25% carbon. So even that small increase in carbon makes a big difference to how the steel interacts. So next there's stainless steel, and this is used in cutlery because it doesn't rust, and you don't want rusting on food utensils. So that was using resources, chemistry topic 10. Thank you. That was Joe Bailey Revision. Goodbye.